Hi, welcome to my channel. This is Kauserwise and this is the continuation video of crashing the network. Already we have seen two different models. Okay, in the previous video we have seen the second model, that is crashing the network with single critical path along with the total float calculation. The links are available in the description box. Now in this video we are going to see the third model, that is crashing the network with single, double and triple critical path in a single problem. Now let's see the problem. See the problem. The following table gives data on normal time and cost and crash time and cost for a project. Okay. So here we have different activities, normal duration and normal cost, and crash duration and crash cost. Okay. So with this data, they're asking us to do three things. Number one, draw the network and identify the critical path. Second one, crash the network fully to find out minimum duration. If direct cost are 300 per day, determine the time cost trade-off for the project. Okay, first we are going to draw the network diagram and we are going to identify the critical path based on the activity and normal duration which is given in the problem. Let's see the network diagram. See the network diagram. If you want to know more about how to draw network, please refer my CPM and PERT videos. The links are available in the description box. See here, the first activity is 1 to 2, normal duration is 5. Then 2 to 3, duration is 6. Then 2 to 5, duration is 4. Then 2 to 4, duration is 5. Then finally 5 to 6, the duration is 3. Okay. So in this problem, for node 3 and 4, there is no successor given in the problem. So we should use dummy activity with zero duration. Okay. Now let's see the second step. See, here I have listed out various possibilities of starting node to ending node to complete the project, how many days it will take. The first possibility is 1 to 2, 2 to 3, 3 to 5 and 5 to 6. So how many days total? 14 days. The second possibility 1 to 2, 2 to 5 and 5 to 6. Duration is 12 days. And the third possibility is 1 to 2, 2 to 4, 4 to 5 and 5 to 6. Duration is 13 days. Okay. Out of these three options, which is the longest path? 14. Okay. So this is the critical path. And this is the simple method to find out the critical path. The another method is we need to find out the earliest start and latest completion time for each and every node, and that is required only if you want to calculate total float and free float. Okay, for crashing the network, that calculation is not required, so that you can apply simple method to find out the critical path. Okay, so according to this calculation, this is the longest path and this is the critical path. Okay, so the critical path is 1 to 2, 2 to 3, 3 to 5 and 5 to 6. And 5 to 6. Okay. The duration is 14 days. Okay. Now let's see the next step. See the problem. So far we have done the first part. That is, we have drawn the network and identified the critical part. The next question is, crash the network fully to find out minimum duration if indirect cost are 300 per day. Determine time cost trade-off for the project. Okay. Now we are going to crash the network to find out the minimum duration. Okay. For that, in order to crash the network, we need to follow three simple steps. See the first step. We need to calculate crash limit and cost slope for all the activities. Okay. See the problem. To calculate crash limit, there is a formula. The formula is normal time minus crash time. See the problem. Normal time is 5 days and crash time is 4 days. What is the difference? 1 day. That is the crash limit for the first activity. In the same way, we need to calculate crash limit for all the activities based on this formula. The second one is cost slope. So this is the formula to find out the cost slope. The formula is crash cost minus normal cost. Crash cost, normal cost. Okay. We have to compare these two things and we have to find out the difference. Divided by normal time minus crash time. Normal time minus crash time. Okay, simply apply this formula to find out cost slope for each and every activity. That is the first step for crashing the network. Okay. See the table of calculation of crash limit and cost slope. We have calculated crash limit and cost slope for all the activities. Okay. Step 1 is over. Now we'll move on to step 2. See, the step 2 is crashing the network. Here we have 3 columns. Number 1, critical path. Under this column, we are going to list out all the possibilities to complete the project. In that, we have to find out the critical one. And the second one, its duration. And the third one, we need to find out the total cost. Okay. See the network diagram. Already we have identified critical path. Okay. Just list out all the possibilities to complete the project, including critical path and its duration and total project completion in the table. See the solution table. We have entered all the paths, okay, including critical path, duration, and which is the critical one. The first one is critical path. The total completion time is 14 days. For that, we need to calculate the total cost. Okay, see the problem. See the problem. See, total cost is equal to total direct cost plus indirect cost. Okay, normal cost is nothing but direct cost. How much? Just find out the total. 8,000 plus indirect cost 300 per day. So how many days it will take to complete the project? 14 days. That is a critical path now, maximum period 14 days. So 14 into 300 is equal to indirect cost. Direct cost 8,000 is equal to total cost. Okay. See the solution table. We have calculated total cost. Okay. So direct cost 8,000 plus indirect cost how much? 300 per day. No. So how many days to complete the project? Critical path 14 days. No. Maximum period. So 14 into 300 plus 8,000 is equal to 12,200. This is the total cost. Now we need to crash the network in order to minimize the duration as well as minimize the cost. Okay. Now we'll move on to step 3. See the third step, that is selection of activity for crashing. Okay. So our ultimate objective is to crash the activity in order to minimize the cost as well as duration. For that, we have to find out the particular activity where we can reduce or crash the activity. Okay. For that, these are the informations are required. Number 1, critical path. We have calculated critical path now. Just enter here and activity. That is 1 to 2, 2 to 3, 3 to 5 and 5 to 6. Enter here. And then crash limit slope for these critical activities. For that, just refer step 1. See the first table, that is step 1. Crash limit and cost slope we have calculated for all the activities. Okay. Now we need to enter only the critical path activities. For 1 to 1, for 2 3, crash limit is 4, for 3 5, 3 5 is not there, that is a dummy activity, no, put dash, and 5 6, no, crash limit is nil. Okay, in the same way we have to enter slope. Just refer the cost slope. For 1 2, 1000, for 2 3, 200, for 3 5, so it is not, it's a dummy activity, no, nil. For 5 6 also slope nil. Just enter crash limit and slope for critical activities. Okay. Now we need to select the least cost slope for crashing the activity. So which is the least value? 200 is the least value. So I am going to crash this particular activity. That is 2 3. But 2 3, so maximum crash limit is 4 days. You can crash 4 days. First, I am going to crash 1 day, then it will become 3 days. Okay. There is no change in the first activity. Enter 1. This will be 3 dash dash. Okay. So, I have decided to crash activity 2 3 by 1 day. Okay. See the step 2 table. Okay. According to the previous calculation, we have found that activity 2 3, we are going to reduce 1 day. No. So, what is the normal duration? 6 days. So, if we reduce 1 day, this will become 5 days. Then the total duration will be 13 days. Instead of 14, it will be 13 days. Okay. Accordingly, it will have an impact in the total cost. Let's see the calculation. But the same activity is not falling in the another parts, another options. So that it is not going to affect the next two options. It is going to be remain same. Say I have reduced 1 day in the critical path. Okay, now the total duration is, so this will become 5, no. So 5 plus 5 plus 0 plus 3 is equal to 13 days. 1 day reduced. For that, the total cost is previous total cost minus 1 day reduced. No, for that, we need to subtract 1 day's indirect cost. Indirect cost how much? 300 rupees. So subtract 300 rupees. And for crashing, you have to incur additional cost. So how much additional cost? See the table of selection of activity for crashing. Okay, so how much you have to incur? 200 rupees. This is the extra cost for crashing the network. See the table of crashing the network. Okay, so plus 200 is equal to 12,100. Okay, it reduced from 12,200 to 12,100. Still you can proceed further until you reach the optimum cost. Okay, that is minimum cost. Say for that again you have to find out the critical path. So in this stage, in the previous stage, we had only one critical path. The first path is critical path because this is the longest path. But in this stage, we have two critical paths because 13 days and 13 days. Okay, so in this case, how to identify which activity we are going to crash? See the table, selection of activity for crashing. Okay, so we have two critical paths. The first one is 1 to 2, 2 to 3, 3 to 5 and 5 to 6. And this is the crash limit after crashing 1 day in the previous step. So this is the crash limit. Okay, now we have second critical path. So this is the second critical path and this is the activity. For that we have to enter crash limit. To record the crash limit and slope, just refer the first table. Okay, for activity 1, 2, duration is 1. This is same, no, 1, 1. Okay. For 2, 4, 2, 4, duration, that is crash limit is 2 days. 2 days. For 4, 5. 4, 5 is not there. That is the dummy activity, no. Just put dash. Then 5, 6. For 5, 6, crash limit is nil. Just put dash. Okay, for that, just record slope also. That is cost slope. How much for the first activity? 1, 2, 1000. 2, 4, 400. For other two activities, dash. That's all. Now, we are going to crash the activity from the critical paths. Okay, for that, we need to select the minimum cost slope from each critical path separately. See the first critical path, the minimum cost is 200 again. Which activity? 2 to 3. The crash limit is 3 days. If I am going to reduce 1 day, it will become 2 days. 1, 2, nil, nil. In the same way, I have to select the minimum cost in the second critical path. So which is the minimum cost? 400. So select this particular activity. That is 2, 4. The crash limit is 2 days. No. If I reduce 1 day, then it will become 1. Okay, now see the table of crashing the network. Based on the previous calculation, we have found that in the first critical path, so which activity we are going to reduce? 2 to 3. What is the duration? 5. So we are going to reduce 1 day. Okay, then it will become 4 days. In the same way, for the second critical path, activity 2, 4. Okay, so what is the duration for 2, 4? 5 days. If I reduce 1 day, it will become 4 days. Then it will become, the project completion time will be 12 days and 12 days. Okay. Accordingly, we have to calculate the total cost. I have reduced 1 day in the first critical path, that is 2 to 3, activity 2 to 3. And in the same way, I have reduced 1 day in this particular activity in the second critical path, 2 to 4, 1 day. So this is the result. Now the total completion time is 12 days. For all the three different parts, we are getting the same completion time. That is 3 critical parts. Okay, in this stage, what is the total cost? As it is, the previous total 12,100 minus 1 day's indirect cost, which is given in the problem. Okay, from 13 to 12 days, 1 day difference, no. So minus 300 plus what is the extra cost? Okay, see the table of selection of activity for crashing. Here I have decided to crash two activities, no, in the first critical path as well as second critical path. The extra cost will be 200 plus 400. Okay, total 600. So 12,100 minus 300 plus 600 is equal to 12,400. See, the total cost start increasing because the previous total cost is 12,100. Now it is increased up to 12,400. Okay, here you can stop the procedure because we have reached optimum cost as well as optimum duration. So optimum duration is 13 days and optimum cost is 12,100. Okay, because it start increasing. Okay, if I move further, again it is going to increase the cost. Okay, for your understanding, let me show the further calculation in order to check is there any changes. See, here we have three different parts. No, now it become all the three parts are critical parts. In this case, we need to find out which activity we can crash in order to minimize the days as well as minimize the cost. Okay, for that, see the table of selection of activity for crashing. Okay, this is the first critical path and this is the crash limit, available crash limit. Second critical path, available crash limit. And the third critical path is activity 1 to 2, 2 to 5 and 5 to 6. For that, just enter the crash limit. So 1, 2 is common for the first critical path as well as second critical path. What is the available crash limit? 1 day. Just enter 1. And then next one, 2 to 5. For 2 to 5, just refer the first step table. Okay. So 2 to 5, the crash limit is 1 day. So write 1 day, 1. For 5, 6, nil. As well as the cost slope value also you have to record. No. For 1, 2, same value, 1000. For 2 to 5, 800. So enter 800 here. For 5 to 6, nil. Okay. So now we have three critical paths, crash limit and cost slope. Again, we have to decide which activity we have to crash. For that, we have to select the minimum cost. Again, in the first critical path, the minimum cost is 200 rupees. Still, we have 2 days crash limit. Okay, we can select this one. See the second critical path. Again, 400 is the minimum. So, we have one crash limit, 1 day. So, we can crash this particular activity by 1 day. And see the third critical path, the minimum cost is 800 rupees. Okay. So, we can select this particular activity. If we crash this particular activity by 1 day, okay. So, 2, 3 is not there in the second and third critical path. In the same way, 2, 4 also is not there in the other critical paths. Again, 2, 5 also is not there in the other critical paths. So, if we reduce 1 day in each critical path, it is going to reduce only 1 day in the total completion time. But the cost will be increased by 1400. The total cost is 200 plus 400 plus 800. It is going to be 1400. So instead, we can go for second option. So what is the other option? Okay, I have to find out the common activity. See here, 1000. That is activity 1, 2. The cost slope is 1000. The same activity is there in the other two critical paths also. So instead of first option, I can go for the second option. So I can select activity 1, 2. The extra cost will be 1000. Now it is lesser than the 1400. Okay. So now I can proceed with this. I'm going to crash activity 1, 2. This is the common activity for all the three critical parts and the cost is 1000 rupees only. Let us see the calculation. See the crashing the network table. If we reduce 1 day in this particular activity, that is 1 to 2, it's a common activity for all the three critical parts. That is 5 days. No. If you reduce 1 day, it will become 4 days, 4 days, 4 days. Then the total completion time will be 11 days. Okay. In this case, what is the total cost? So previous total how much? 12,400 minus 1 day reduced. No. So indirect cost is 300 minus 300 plus the extra cost, slope cost. How much? 1000 rupees. So add 1000 rupees. The total cost will be 13,100. Just compare with the previous calculation. So this amount is greater than the previous calculation. It's keep increasing. So already we have reached the optimum level. This is the optimum cost, 12,100. This is the least cost. So this is the optimum one. So optimum cost is 12,100 and optimum project completion time is 13 days. For your understanding only, I have done this calculation. Okay, you can stop the procedure till this. Therefore, the optimum project completion time is 13 days and optimum total cost is 12,100. Okay, so this is the way to crash the network problem. Hope you understand this concept. Please hit the like and comment, subscribe and share with your friends. Thank you.